Students, now we can see our next topic is volume, correct? So in this video we will see what are the volumes of different shapes, correct? So we are using from cube or cuboid. We are starting from cuboid. So your first shape is cuboid. Okay, students, you know very well what is a cuboid. If length of the cuboid be L and breadth be B and height be h, so volume of cuboid, this will be L into B into h. We can write length into breadth into height. Now we will see volume of cube. Students, if all the sides means length, breadth and height are equal in a cuboid, so this will be a cube and side of the cube be A. What is the volume? Volume will be side into side into side, A into A into A, so this will be A cube. Now our next shape is cylinder. So students, we have a cylinder and what is the radius? Radius be R and height be h. So what is the volume of this cylinder? Volume will be pi r square h, correct? This will be pi r square h. Now our next shape is a cone. Students, we have a cone here, okay, and the base radius be r and height of the cone be h. So volume of cone, this will be 1 by 3 pi r square h. Okay, now we have a sphere. If sphere, we have radius of the sphere be r, then the volume of sphere, volume will be 4 by 3 pi r cube. Students, now we have a hemisphere, means half sphere. Hemisphere, you can see here a hemisphere, and if the radius be r, so what is the volume of hemisphere? Half of the sphere. So volume will be 2 by 3, half of 4 by 3 will be 2 by 3 pi r cube. So students, these are the volumes of different shapes. A solid is in the shape of a cone standing on a hemisphere with both their radii being equal to 1 centimeter, and the height of the cone is equal to its radius. Means radius and height of the cone both are same, that is equals to 1 centimeter. Find the volume of solid in the terms of pi. Students, we have to find volume of the solid in the terms of pi. We are making figure with the help of this given data. Students, we have a hemisphere, correct? We have a hemisphere, and what is the radius of this hemisphere? This is given here 1 centimeter, and the radius is equals to height of the cone. This is also 1 centimeter. Suppose height of the cone be h, this is 1 centimeter, and radius of cone and hemisphere both are same, this is 1 centimeter. Students, we have to find volume of the solid, so it's very easy to find volume. We will add volume of both the shapes. What is the volume of cone? This will be 1 by 3 pi r square h, and what is the volume of this hemisphere? This is 2 by 3 pi r square h. So volume of solid, this will be equals to volume of cone plus volume of hemisphere. Okay, students, what is the volume of this cone? This is 1 by 3 pi r square h plus volume of hemisphere, this will be 2 by 3 pi r cube. Now values are given here. We will put the value of h and r. We will not put the value of pi because we have to find answer in the terms of pi. So we will write here 1 by 3 pi, the value of r, this is 1 square, and h is 1 plus 2 by 3 pi, and the value of r, this is also 1 cube. Okay, now this will be 1 by 3 pi into 1, this will be 1 by 3 pi plus 2 by 3 pi into 1, this will be 2 by 3 pi. Now 3 is LCM, and we will write in the numerator 1 pi plus 2 pi, this will be 3 pi over 3 pi, sorry, 3 pi over 3. So pi cancel out, so this will be pi centimeter cube. The volume of the solid will be pi centimeter cube. Rachel, an engineering student, was asked to make a model shaped like a cylinder with two cones attached at ends by using a thin aluminium sheet. The diameter of the model is 3 centimeter and its length is 12 centimeter. If each cone has a height of 2 centimeter, find its volume. Students, according to this data, we will draw a figure. They are saying an engineering student is making a model, and we have a cylindrical part, and there are two cones attached on both the ends like this, and radius is given here, and total length of the model is given here. What is the total length of the model? Total length of the model is given here 12 centimeter, correct? And what is the height of this cone? This is 2 centimeter. So students, we are writing here 2 centimeter. This height is also 2 centimeter. Students, we can see here this whole part is 12 centimeter in length. This is 2, this is 2. The height of this cylindrical part will be 8 centimeter. Correct? Now what is the radius? You can see here the radius of the model is given here. Correct? Diameter is 3. So radius will be 3 upon 2. So radius of the model be 3 by 2 centimeter, and length of the cylinder, this will be h, and height of this cone, this will be h dash. So you can write here the value of h dash, this is 2 centimeter, and the length of the cylindrical part, this is h, 8 centimeter. It's very easy to find volume of this model. Correct? We will find volume by using volume of cylinder plus volume of two cones. We will add directly volume of these shapes. So we will get volume of this total model. Volume of the model, this will be volume of cylinder plus 2 into volume of cone. 2 into volume of cone. Correct? Now what is the volume of a cylinder? We know very well, formula will be pi r square h plus 2 into volume of cone. We know very well, this is 1 by 3 pi r square into h dash. H dash is the height of the cone, but radius is same, so we are using here r square. We are putting the value of pi, this is 22 by 7, radius, this is 3 by 2 whole square, into height. What is the height of this cylindrical part? This is 8 plus 2 by 3, the value of pi, this is 22 by 7, and the value of radius r is 3 by 2 whole square, and the value of h dash, this is 2. Correct? Now what will we do here? We will write here 22 by 7, 3 by 2 into 3 by 2 into 8. Correct? This will be 2 by 3 into 22 by 7 into 3 by 2 into 3 by 2 into 2. Now students, 2 cancel out, and 2 4 ja 8 and 2 2 ja 4. Now you will do multiply by 2, 3, 3 and 22, and you will divide by 7. You will get any number here. Okay, you will do multiply 2, 22, 3, 3, and you will divide by 3, 7 ja 21, 42. You will divide by 42, you will get any other number, you will add both the numbers, so you will get your answer. Students, we have 22 by 7 into 3 by 2 into 3 by 2 multiply by 8. After solving this part, we will get here 56.57 plus after solving this part, we will get here 18.85. You will add both, so you will get here 75.42 centimeter square. So this will be the volume, sorry, centimeter cube. This will be the volume of this model. A gulab jamun contain sugar syrup up to about 30% of its volume. Find approximately how much syrup would be found in 45 gulab jamuns, each shaped like a cylinder with two hemispherical ends with length 5 cm and diameter is 2.8 cm. Students, this figure is given in your question. What is the total length of this gulab jamun? This is 5 centimeter and radius of the hemisphere be 1.4 centimeter. 1.4 centimeter, correct? Now you have a gulab jamun in the shape of a cylinder and two hemispheres attached on both the ends. Okay. Now we are writing here, we are writing here height of the cylindrical part. This is 5. 1.4 minus 1.4, so this will be 2.2 centimeter. This will be the height of this cylindrical part. Students, we can write here height of the cylinder be 2.2 centimeter and radius of cylinder and hemisphere both are same. This is 1.4 centimeter. We have to find what is the amount of the syrup. Students, one more thing, they are saying 30% is sugar syrup. Okay, suppose we have a gulab jamun, the weight of the gulab jamun, volume of gulab jamun is 100 centimeter cube, then 30 centimeter cube will be the amount of sugar syrup, means volume of the sugar syrup. Okay, now we are finding volume of gulab jamun is equals to volume of cylinder plus 2 multiplied by volume of hemisphere. Okay, now volume of cylinder, this is pi r square h, and 2 into volume of hemisphere, we know very well 2 by 3 pi r cube. Now we are putting the values. What is the value of pi? This is 22 by 7. And what is the radius? Radius is 1.4. We have square, so 1.4 into 1.4 into height of the cylindrical part, this is 2.2 plus 2 to the 4 by 3, and value of pi, this is 22 by 7. And radius, what is the radius of this cylinder and hemisphere? Both are same. This is 1.4 cube, means 1.4 into 1.4 into 1.4. Now 7 to the 14, 7 to the 14, so 0.2 0.2. After calculating, we will do multiply all the number, and dividing by 3. After solving, we will get here 25.05 centimeter cube. This is the volume of one gulab jamun. Students, if volume of one gulab jamun is given, how will we find volume of 45 gulab jamun? So we will do multiply by 45. So volume of 45 gulab jamuns is equals to 45 into 25.05. If you will do multiply of both, so you will get here 1127.28 centimeter cube. So this is the volume of 45 gulab jamuns. Now we will find amount of sugar syrup. Volume of sugar syrup, this will be 30% of volume of gulab jamuns. Okay, so we are finding 30% of 1127.28. You will do calculation 30 upon 100 into 1127.28. After doing calculation, 0 0 cancel out, you will do multiply by 3 and divide by 10. We will get here 338.18 centimeter cube. So students, this will be the amount or volume. This will be the volume of sugar syrup. Students, a pen stand made of wood is in the shape of a cuboid with four conical depressions to hold pens. The dimensions of cuboid are 15 cm by 10 cm by 3.5 cm. The radius of each depression is 0.5 cm and depth is 1.4 cm. Find the volume of the pen stand. Okay, so we are making a figure by this data, by this given data. How will we make? We have a pen stand in the cuboid shape. Students, you can see here we have a pen stand in cuboid shape, and there are four conical depressions. We are making here four conical depressions: 1 to holding pen, 2, 3 and 4. Okay, now dimensions are given here. Students, what are dimensions? The length of the cuboid, this is 15 centimeter, and breadth is 10 centimeter, and height is 3.5 centimeter. Correct? So these are the dimensions of cuboid, and we have a cone here, conical depression like this, and they are saying the radius of the cone. What is the radius of the cone? 0.5. Radius is 0.5 centimeter, and depth means height of the cone, this is 1.4 centimeter. Okay, we have to find volume of this pen holder or pen stand. You can say volume of pen stand is equals to volume of cuboid minus volume of four cones, because we are cutting out cone and we are taking out from this cuboid. Okay, so volume of pen stand is equals to volume of cuboid minus 4 into volume of cone. Volume of cuboid, we know very well, length into breadth into height, minus 4. Volume of cone, this is 1 by 3 pi r square h. Students, we know very well what is the length. This is 15 centimeter, and breadth, this is 10 centimeter, and height, this is 3.5 centimeter. About cone, we can say radius r 0.5 centimeter, and height h dash, this will be 1.5 centimeter. Correct? Now we are putting all the values. The value of length, we know very well, this is 15 centimeter, and breadth, this is 10, and height, this is 3.5 centimeter. Correct? Minus 4 by 3 into pi, this is 22 by 7, into radius. What is the value of this r? This is 0.5 whole square, 0.5 into 0.5 into h. What is the value of this h? This is 3.5. Correct? Now 0, we will remove this point from here, and 7 5s are 35. Correct? If you will do multiply 15 and 35, so we will get here 525 minus, we will do multiply by 4, 22, 0.5, 0.5, 0.5. Okay, and divided by 3, so we will get here 1.47. When you will subtract 1.47 from 5 to 5, so we will get here 523.53 centimeter cube. So this will be the volume of this pen stand. A vessel is in the form of an inverted cone. Its height is 8 centimeter and radius of the top, which is opened, is 5 centimeter. It is filled with water up to brim. when lead shot, each of which is a sphere of radius 0.5 centimeter, are dropped into the vessel, 1/4 of the water flows out. Find the number of lead shots dropped in the vessel. Students, we have a inverted cone here, correct? So we have inverted cone here, and this is filled with water up to brim. It is filled with water up to brim. Now what is the height of this vessel? Height of the vessel is 8 centimeter, and radius, what is the radius? Radius is 5 centimeter. Radius of this vessel is 5 centimeter. Now we have some lead shots, spherical lead shots here, and radius of each sphere is given here. This is 0.5 centimeter, correct? So radius, suppose this will be small r, 0.5 centimeter, and capital R is radius of the cone, this is 5 centimeter, and height of the cone will be capital H. Okay, now we are dropping these lead shots. We don't know about how many lead shots are there. We have to find number of lead shots. We are dropping these lead shots in the vessel, and 1/4 water is coming. 1/4 water is coming from this vessel. Okay, so we have to find number of lead shots. Students, we know very well, we will use a formula here, n into volume of one lead shot is equals to 1/4 into volume of cone. Students, you know very well Archimedes principle, है ना? According to this principle, we will use here n means number of lead shots into volume of one lead shot is equals to 1/4 water is coming out from this vessel to 1/4 volume of cone. We will write here let the number of lead shots be n. Okay, now students, n into volume of one lead shot. Lead shot is in the form of a sphere, so volume of a sphere, this is 4/3 pi r cube, and radius of this sphere is small r, is equals to 1/4 volume of cone, this is 1/3 pi r square and h. Now pi cancel out, 3 cancel out. We will get here n is equals to r square into h upon 4r, 4 4 ja 16. Right here 16 r cube. Students, we will put all the values here. What is the value of capital R? This is given here. Capital R is 5. 5 square means 5 into 5. And what is the height of the cone? This is 8 over 16 into small r. This is 0.5. Cube means we will write here 0.5 into 0.5 into 0.5. Correct? We are removing these 3 points. We are increasing 3 zeros. 5 cancel out, 5 cancel out. Now 16, 5 ja 80, so 500, and 5 1 ja 5. This is n equals to 100, means the value of n is 100. You can say 100 lead shots can be dropped in this vessel. So 1/4 water is coming from this vessel, so your answer will be 100 lead shots. A solid iron pole consists of a cylinder of 220 centimeter and base diameter 24 centimeter, which is surmounted by another cylinder of height 60 centimeter and radius 8 centimeter. Find mass of the pole given that 1 centimeter cube of iron has approximately 8 gram of mass. Students, they are saying use pi equals to 3.14, means the value of pi is 22/7 also, but we have to use here 3.14. They have written in the question. Students, they are saying we have a cylindrical pole. We are making a pole, cylindrical pole, And the radius, what is the radius of this pole? In first part they are saying diameter is 24, so radius will be 12 centimeter. Radius is 12 centimeter and height is 220 centimeter. Correct? Now this is surmounted by another pole. This is surmounted by another pole. And what is the height? Height is 60 centimeter. And now radius is given here. Radius is 8 centimeter. Correct? We have two cylinders. One is large and one is small cylinder. Height is capital H and radius be capital R. Height be small h and radius be small r. Correct? Now you have to find volume of this pole. Volume of large cylinder plus volume of small cylinder. You will add both the volumes because we have two shapes here. So volume, we can write here capital H, this is 220, and capital R, this is 12 centimeter. Small h, this is 60 centimeter, and small r, this is 8 centimeter. Now volume of pole is equals to pi capital R square h plus pi small r square h, means volume of large cylinder plus volume of small cylinder. What is the value of pi? They are saying use 3.14. And radius, what is the value of small r? Sorry, capital R. So capital R is 12 square into height. What is the height of the pole? 220 plus pi, this is 3.14, and small r, radius is 8 square, 8 into 8, and height is given here 60. Okay, now we will solve this part. 3.14 into 12 square, 12 into 12, and this is 220 plus 3.14 into 8 into 8 into 60. After solving, students, we will get our answer. A solid consisting of a right circular cone of height 120 centimeter and radius 60 centimeter is placed upright in a right circular cylinder such that it touches the bottom. Find the volume of water left in the cylinder if the radius of the cylinder is 60 centimeter and height is 180 centimeter. Students, we have a solid which is in the shape of a hemisphere and a cone. And what is the radius? Radius of the hemisphere be 60 and height of the cone be 120 centimeter. Correct? We have a vessel. The radius of the vessel is 60 centimeter and height is 180 centimeter. So we are keeping this solid. This is full of water and we are keeping this solid inside the vessel. So they are asking how much water will left inside the vessel. Correct? Now we will subtract volume of this solid from volume of cylinder. Correct? So we will write here volume of water left in the vessel. This will be volume of cylinder minus volume of cone minus volume of hemisphere. We are subtracting both the volumes from volume of cylinder. The height of the cylindrical part be capital H and radius be capital R, or you can write here all the radii are same, so small r, and height of the cone be small h, radius will be small r. Students, we are applying formula. Volume of cylinder, this is pi r square and h, minus volume of cone, this is 1 by 3 pi r square h, volume of hemisphere, this is 2 by 3 pi r cube. We are putting the values. Value of pi, this is 22 by 7, and radius, this is 60. So 60 into 60 we can write here, and height is 180 minus 1 by 3 pi, this is 22 by 7, radius, this is 60 square, so 60 into 60, and height is given here 120. Minus 2 by 3, pi this is 22 by 7, and radius this is 60. So 60 into 60 into 60. Correct? Students, after solving this part, volume of this cylindrical vessel, this will be 2034720 centimeter cube. Correct? Minus, after solving this part, 3 4 ja 12, 40. Multiplying and dividing by 7, we will get here 452160 minus, solving this part, we will get here 452,160. Okay, after solving, we will add both the numbers and we will subtract from this part. We will get here 1130,400 centimeter cube. So this will be the volume of water left inside the vessel. This will be our answer.